Next question. Show that the relation, 12th question from exercise 1.1. Show that the relation R defined in the set A of all triangles as R equal to set of all T1, T2. T1 and 2 are two triangle T1, T2 such that T1 is similar to T2 is equivalence relation. Similar, you have studied about congruent triangle, similar triangle, all those. So in this you have to show that this R T1 similar to T2 is equivalence relation. So if it is show that, you have to prove that this R is reflexive, symmetric and transitive. So you are having reflexive condition. What is reflexive? A comma A. In this case you can take it as, because you are having T1, T2. So you can take it as T1 and T1. T1 and T1 should be belongs to this R. So condition will be similar. So you should be able to write T1, T1 such that T1 is similar to T1. അതായത് T1, this triangle will be always similar to itself. Property of similarity of triangle. Triangle will be always similar to itself. So you can write T1, T1 belongs to R. We know that each triangle is similar to itself and thus T1, T1 belongs to R. Therefore, R is reflexive. Again, for symmetric, if I am taking T1, T2, T2, T1 should belongs to this R. So here you are having two triangles, T1 and T2. If this triangle is similar to T2, vice versa, this triangle will also be similar to this T1 when you are having two triangles. E triangle ഒരുപോലെ ആയിരിക്കും. So this will be written as, also two triangles are similar, then T1 similar to T2 implies T2 similar to T1. Therefore R is symmetric, because when taking two triangles, same type of triangle, these two will be similar to each other. So you can write T1, T2, T2 and T1. Again, for transitive we want three triangle T1, T2 and T3. ഇത് രണ്ട് അങ്ങോട്ടും ഇങ്ങോട്ടും സിമിലർ ആണെങ്കിൽ T1 and T2 similar, T2 and T3 also similar, then first and third triangle will be also similar. അതായത് T1 is similar to T2, T2 is similar to T3, then T1 is similar to T3. That is T1 similar to T2, T2 similar to T3 implies first and third triangle will be always similar. So therefore R is transitive. Therefore R is an equivalent relation. അതേപോലെ next question. Let L be the set of all line in xy plane and R be the relation in L defined as R equal to set of all L1, L2 such that L1 is parallel to L2. Show that R is an equivalence relation. First thing, it is solve here. After that, I'll tell about this question, this part of the question. As you have had T1 and T2 triangle, similarly you are having here L1 and L2 as line. For reflexive condition, L1, L1 should belongs to R. Always the line is parallel to itself. So this line will be parallel to itself. So you can write L1, L1 belongs to R. L1 is parallel to L1. Therefore R is reflexive. See here, R equal to set of all L1, L2. L1 is parallel to L2. L1 parallel to L1. Line is parallel to itself. So you can write L1, L1 belongs to R. R is reflexive. Again, for symmetric condition, you want two lines, L1 and L2. If L1 is parallel to L2, vice versa, L2 can also be parallel to L1. This two line eduthalu L1 and L2 രണ്ട് line അങ്ങോട്ടും ഇങ്ങോട്ടും parallel ആയിരിക്കും. So you can write if L1 parallel to L2, then L2 parallel to L1. So you can write R is symmetric. When you are taking three line, L1 parallel to L2, L2 parallel to L3. ഇത് രണ്ട് parallel ആണെങ്കിൽ first line third line parallel ആയിരിക്കും. If you remove this second line, 1 and 3. Rough diagram ആണ്. This L3, L1, L3 will be parallel. അതായത് L1 parallel to L2, L2 parallel to L3, then this L1 will be parallel to, always parallel to L3. So if L1 parallel to L2, L2 parallel to L3 implies L1 parallel to L3. So here you can write R is transitive. Therefore R is an equivalence relation. Next you are having this part of the question, second part. Find the set of all lines related to the line y equal to 2x plus 4. You have to find all set of lines that is related to this line equation y equal to 2x plus 4. I think you have forgotten the equation of line. I am writing here. This is equation of line. Few may remember this equation. What is it? Y equal to mx plus c. So here m is your, do you remember what is m? M is slope. C will be constant or any real number. So you are having equation of line, that is y equal to mx plus c. In this question you are having y equal to 2x plus 4. This is your question. So you have to find all the lines related to this line. So simply you have to write, just you have to write what is m. So y equal to mx plus c. M is your 2, x is x itself, and c is your 4. M equal to 2, c equal to 4. Therefore, set of all lines related to the above line. Which is your above line? This one. So that you will get the answer for your this line. Y equal to 2x. In the place of 4, you have to write only c, because you have to find all the lines. So this c can be any number. Here it is 4. You can write it as 5, 6, any number. So the answer for this question, this part of the question, y equal to x plus 4, and this we are having all the lines related to the above line. So that will be y equal to 2x plus c. This is your answer. Just you have to write in the place of 4, you have to write only c. That is from this main equation. Slope you cannot change, but real number you can change. So slope I cannot change. I am writing as it is 2 and 2. But here c is your constant. So for here it is 4, and here in your answer you can write it as c or k, any small letter k or c, any constant. But you have to write k belongs to real number r. If you are writing it as p or q, you have to write p belongs to this r. So that's all for today's class. Hope you have understood. And if you have any doubt regarding these, all these questions are very important. So please go through the video, and if you're having any doubt, please feel free to ask me. Thank you.